Alright, welcome back, everybody. Let's get started on 7.4. In 7.4, we are doing the double angles and half angles. Math 54, 7.4 is on. The more important one here is the double angles. Double angle formula, and we're gonna have the half angle formula. Double angle formula comes up all the fucking time in calculus. Half angle formula very rarely. Before I get into that, if you're gonna write pi. You can do it with a curl, you can do it where it's flat. Don't do that. No. That actually is a symbol in mathematics, it means gamma. This is. I think gamma. But it's got a notation in mathematics. Stick with doing pi's like this. So the person that lost 0.01 points on it, their pi's look like that, and I wanted to make sure that they were aware of it, because your later teachers aren't gonna. I knew what I was looking at, because I'm looking at the trig wheel. You're in a circle, and I knew I was looking at pi, but like later on. Your next teachers might see it and go, what the fuck is this? Nope, that ain't right. Doesn't look anything like pi. So just be aware of that, alright. Double angle formulas, how do they work? Someone remind me, what was the formula for cosine of A plus B? Oh, pop quiz.
Cosine A times cosine B minus sine A times sine B.
Holy shit, you get a cookie, if I had a cookie. Minus sine A, sine B, right? Someone's did some work on 7.3 or paid attention and remembered it. Or just looked at his notes right before this.
I did not, I swear.
So if I wanted to get something like cosine 2A. I'm showing you how it's derived. 2A double angle. Double angle A. I could do this as A plus A. So. This ends up being cosine A, and wherever I had a B, I'm gonna put in an A. So the first form of cosine 2A. Is cosine squared A minus sine squared A. And I use A because we had A plus B in those formulas, but if it's you have theta in there instead, that's just a thing. It's just a placeholder for the angle thing. There are two other variants of this. And the other variants of this stem from sine squared A plus cosine squared A equals 1. So depending on which one I solve for, if I solve for sine squared A, I would get 1 minus cosine squared A. And if I solve for cosine squared A, I get 1 minus sine squared A. This is a different formula, that's the Pythagorean formula. But if I substitute this one in. I would get cosine squared A minus, in parentheses, 1 minus cosine squared A. And we'll distribute that sign, minus 1 plus cosine squared A. So the second form of this is 2 cosine squared A minus 1. There are 3 variants of this and they're all used just as much. In fact, I think the top one is used the least, to be honest. And the one that's probably used the most is if we plug in cosine squared A. If I plugged in cosine squared A, replace it with 1 minus sine squared A. Then I have minus sine squared A. I don't even need the parentheses here, I've got minus sine squared and minus another sine squared. I have minus 2 sine squared A. All of these are cosine 2A. And these two are used the most frequently. In higher mathematics. We can switch from a double angle down to a regular single angle, and we've only got one trig function, not two. That's why this top one is not our favorite. The top one has two trig functions. So I'll write them all in a box in a second after we do the other two. What was the formula for sine A plus B?
Sine A times sine B.
No. They did not match
Sine A cosine B.
cosine B. What's sine here?
Plus
Plus.
same sign.
Yes,
The same
sine has the same
word.
sign, cosine has the opposite sign. And then you switch which letters are which in which trig functions. So if I want to do sine of A plus A. I have sine A cosine A. Plus cosine A sine A. And that leads us to one of the more important ones, sine of 2A. Is 2 sine A cosine A. Or theta, sine of 2 theta is 2 sine theta cosine theta. I was sitting in here earlier. Waiting for the animal science teacher, is that what he teaches? What's the class actually called? It's called feed. Okay. The students are asking a bunch of questions, and someone asks. Like their dog is getting old, he's like, yeah, my dog's getting old too, it's 15. Most dogs of that breed live till 12, but I feed it this particular brand. And he's like, it's $90 a bag, I'm like, oh shit, that's an expensive dog food. But if your dog lives. Still like, it's still moving around, no signs of being in pain or anything, but they're getting old, obviously. But moving around without pain, 3 years after the average life expectancy for a dog, that's a long time after the average life expectancy. Maybe, my dog's not that big, maybe I can buy a $90 per pound, or $90 bag of food, cause it'll last that little fucker a while. It ain't that big. Depends on how close you are to your pets, you know, I don't have kids, that is our kid.
Right, 2 pounds, 2 pounds. 90 pounds. It's not covered.
Alright, we got one more look at before we do our box. Alright. Patrick. Tangent of A plus B, you wanna. Fucking show off, or Lewis, you got this one, Lewis? You gonna show off, show Patrick around, who's got this one?
I know it's a fraction, I know there's like it's tangent A plus tangent B over 1 minus something, forgetting what is it?
You got a good start. Tangent A over plus tangent B over 1 minus.
Them times each other, right, tangent A times.
Times each other. That's pretty good, I don't, I struggle, I remember it now, because that's just because I've been teaching for 10 years, 9 years. But like that one's a hard one to remember, I don't know why. Cosine and sine were easy to remember. The fucking fraction thing. So if I want, I'm gonna switch to theta here, if I want tangent of theta plus theta. Or two theta. A double angle. I'm gonna have tangent theta. Plus tangent theta. Over 1 minus tangent theta. Tangent theta. Green pen is dying. David doesn't look impressed. Not even writing down, it's like this shit's easy, trivial. So if you clean this one up. You will have. Tangent of 2 theta. Equals 2 tangent theta. Over 1 minus tangent squared theta. And now I'll write my other ones down here. So we can have them all on the same page, all with theta. Because that's what you're more likely to see. There's your double angle formulas. Show you guys something Victor put on his test for his unit circle that I think if you've seen him before. Will really help you quickly on like getting your trig values. He had the 45, 45, 90 triangle in. These are common in engineering. Or architecture or construction. And the 30, 60, 90 triangle. And that one is 1, that one is 2, that one is square root of 3. And on this one, it's 1, 1 square root of 2. So like from this, you can do sine 45, cosine 45, doing opposite over hypotenuse, adjacent over hypotenuse. Or tangent relatively quickly, and then if you want sine 30, or either the 30 or 60 degrees. You jump over to this triangle. And do sine, cosine, or tangent off of that. But they are well-known triangles. The only one thing that's like tricky about it to remember is. You're gonna wanna say 30 has the 1, 60 is twice that, you're gonna wanna put the 2 on the opposite side of 60. If you're like me. And it's not, the 2 goes on the hypotenuse. Alright, you guys ready to work with some double angle formula stuff? Alright, don't fucking slide. Back to your page, Jesus. Trying to get to move and don't wanna move. That way we can still see it. So if. Cosine theta is. Let's say -12/13. And sine theta. Is greater than 0. Find. Sine of 2 theta, cosine of 2 theta. And tangent of 2 theta. Any ideas on how we could approach this?
Sine theta into the double angle formula. By. That's the only like value we're given, sine's over greater than 0, but cosine theta is the only like exact value we have.
So we could find the cosine 2 theta pretty easy with this one, right? What about the other two? That's a valid approach. Let's start with the one he said. So if I wanna do cosine 2 theta. I can do 2 cosine squared theta minus 1. So this is 2 times -12/13 squared minus 1. See, that is 2 times 144/169. Looks like we're gonna have a denominator of 169, so I'm gonna turn the 1 into a 169/169. That's 288 minus 169/169, which is 110, 11, 19, 119/169. Alright, we got the easy one out of the way. Yeah, that was the easy one, the rest we gotta work for.
You got the sine 2 theta equation that has cosine theta and eats, because you plug that in, so you're well important words.
Well, in this one, we don't have sine 2 theta or sine theta, so we're gonna have 2 things we don't know. Having 2 things we don't know is not good. If you wanna solve for one thing, you gotta have only one variable left. What can we do with this piece of information?
Quadrant,
It does narrow down the quadrant, what quadrant are we in?
yeah, cosine negative. Gonna be
Quadrant 2. Over here, cosine is negative and sine is positive. And we can do a reference angle thing, the reference angle will be that angle. Cosine is adjacent over hypotenuse. I have a 12 and a 13, one of them's gotta be negative. Which one should I make negative? And why? 12, why?
That's going left on the x-axis, isn't it?
We're going left on the x-axis is negative. And this is usually like the radius of a circle, if we did the whole circle, radius is always positive. You want your hypotenuse to be positive. So what does that tell us about sine theta? Can we figure it out from this? And if so, how?
Get the a squared plus b squared, c squared. Get that,
We can't. I'm gonna call this y, this is a y height, we could have used a squared plus b squared. But it's this side. Squared plus this side squared. Equals the hypotenuse squared. Come on, screen. So 12 squared is 144. The negative goes away because we're squaring it. 13 squared is 169.
fine,
Get y squared by itself. And we take the square root. We normally take the square root, we get plus or minus. In this case, which one is it? It's the positive one. If we were in quadrant 3 or quadrant 4 down below, we would use the negative one. So keep in mind, don't just automatically assume that you're gonna use the positive one. It's quadrant dependent. But now I should be able to get sine theta and tangent theta directly from it. Sine theta is what? 5/13, opposite over hypotenuse. So Catella. What is tangent theta? Opposite over adjacent, -5 +. Alright, well, that was our cosine 2 theta, we weren't looking for sine theta and tangent theta. We were looking for sine of 2 theta and tangent of 2 theta. So sine of 2 theta, we'll just use the formula for it. That sine theta was 5/13. Cosine theta was -12/13. The sine of 2 theta equals. That looks like -120/169. Put all this shit out.
eight.
You might have the same variation I print out. I just change the questions sometimes, cause like the previous videos have these questions, so I try to change the numbers sometimes.
Oh, okay. That,
The problem that it came with is sine theta and
yeah.
different stuff.
That,
I tried to print it out. But it gives you a watermark.
no, it's plain. There's like a little icon if you hover your cursor.
If you guys wanna print them out, I'll upload the clean ones to Canvas. Okay. Someone, if I don't do it by like. Wednesday night, email me someone or text me. Cause I gotta teach class after this and shit, we still got an hour and 20 minutes left of this, I'm not gonna remember. We got one more to do. Tangent 2 theta. That is 2 tangent theta. Over 1 minus tangent squared theta. So 2 times -5/12. All over 1 minus -5/12 squared. So I'm gonna continue this on over here. The top is -10/12, I'm not gonna reduce it yet. The bottom has 1 minus 25/144. And I'm gonna replace the 1 to get a common denominator with 144/144. I'm doing this without the calculator, if you do it in a calculator, it'll go faster. So you got -10/12. This is 119/144. And then you multiply by the reciprocal of the bottom. So 144 is 12 times 12, this 12 will cancel that 12. And 119, I think is prime. So I've got -120 over 119. That cancels that cancels that. That looks about right. And that's tangent 2 theta. Oh shit, they used the -12, 13. We'll use it for the cosine 2 theta, oh, tricksy. Alright, Sean, David.
I'm just trying to comprehend this stuff.
Oh, it looks like you're having fun, I don't know if I can allow that. If you're having fun, I'm not being fierce enough. Do you have any questions, anybody? So use your starting information to figure out what quadrant you're in. Use that quadrant to draw a picture, make your triangle, and fill in the missing value. Once you have the missing value, we had sine theta, cosine theta, tangent theta. Now you're just plugging the shit into the formulas and you're grinding out some arithmetic. Well, it's not necessarily nice arithmetic, it's fraction heavy, but. If you do it in a calculator right. You can get the right answer. It can be a bitch and this shit, like the tangent one. I could see people easily fucking up entering this in a calculator. Easy. Did anyone else get -120/119? Like doing using a calculator? Or by hand? Like, I ain't gonna lie, I make mistakes all the fucking time too. But I try to do it by hand whenever I can. It's good for your brain. You get better and faster at doing basic math the more you do it. By hand or in your head. The more you rely on a calculator, I think you're slowly dumbifying yourself, to be honest. It's what ChatGPT is to every subject now. Calculator is the math, but ChatGPT is every subject. I wish it was right more often. Well, I'm kind of glad it isn't. It would make my job a whole lot harder. It's really easy to grade a lot of shit with. You would think, like in trick class, your tests are in person, and it's easy to, you're not using ChatGPT. But like the programming class, they'll program, they'll pull up shit, and I'm like, there's no way in hell I know you know how to do this. Submit some like high, it doesn't fuck up programming code very often. It does, it's really good, 'cause it's based on programming code. So it doesn't fuck that up, when you're teaching introduction. And you've only covered some basic shit and they're whipping out some shit that I gotta look up. Yeah, I'm calling bullshit, I'm fucking cheating. Alright, next problem. I think we need to. I need to change it up on David here, cause now he's looking at the other one. I don't know, David, you want me to go with the one you see on the paper in front of you?
No, I can't hardly follow, it takes me so long to even know what I'm looking at, so. This is.
I assume you're looking at this page. Does the next one say cosine two theta?
Probably,
Are you even on the right page? Do I need to come help you find the right page?
you look around 714 pages, I can give a page number.
I don't know what page it is, I'm on section 7.4.
Yeah,
It should be they might have changed it, this is, might be the last edition.
sure, we can turn that down.
Well, so they should be, unless you change the order of the pages you printed out. 7.4 should be in order.
I think I'm somewhere right.
You'll have to show me which one you have at breakdown this thing. Ah, he's like, fuck you, we're doing it now.
It's helping me a little bit having this printout.
Oh, yeah, oh, this is the actual book.
Yeah, there's a way you can print out the pages I found out.
I will yeah, this one is a little harder to print out, but. Like this one is like a study guide version that they have
Oh,
on
your system.
on their website, yeah. I'll upload this and you might like it. Alright, next problem, it should be going through the topics in the same order though. Presumably. We're gonna say sine of two theta. Equals. What do we wanna use? Four-fifths. And theta is in, let's say 180 degrees, 270 degrees. Find the six trig functions. Wait, let's make this cosine. I don't know that we can do this one with sine. So. We can use one of the cosine double angle formulas. I'll pick this one to start with. We know what cosine 2 theta is, but we don't know what cosine theta is. So we'll solve for cosine square or cosine theta, we'll add 1 to both sides. 1 is the same thing as 5/5. So if we do that, we have 9/5 equals 2 cosine squared theta. I'm gonna multiply by 1/2 rather than divide by 2 because it makes it easier to do the other side. And we get 9/10 equals cosine squared theta. And if we take the square root. And to put the cosine theta on the left. Square root of 9 on top is 3. Got square root of 10 on bottom. If I rationalize this by multiplying top and bottom by square root of 10. I get 3 root 10 over 10. And this is a plus or minus. So let me write that over here where I doesn't look so much like a clusterfuck. Can I determine which sign it is? How? What? It's in quadrant 3. What is the sign of cosine in quadrant 3? 180 to 270 is in this region. Cosine's negative. So we're gonna have cosine theta. You know what, I'm gonna use the 3 over root 10 for now. Cause it might be easier to make the triangle with that. I'll show both. But if I'm gonna make that triangle here, I'm making a reference angle with the x-axis. And cosine is adjacent over hypotenuse. So we'll put the square root of 10 down here, the 3 up here. And just like in the last problem, we got a negative here. This is one way to do it. We could have gone back and done the same thing with cosine 2 theta equals 1 minus 2 sine squared. And found sine theta the other way, using the other formula. But I don't think anyone likes doing all the algebra. It might be easier just to do this little triangle thing. I don't know what that value is, I've got y squared plus negative 3 squared. Equals square root of 10 squared. So y squared plus 9 equals 10. If you go this route, you lose the fractions for a lot of it, and most people don't like working with fractions. So this is the route I would do, but I've seen students grind out the hard way with the formulas. We solve for y. I get y squared equals 1. If we take the square root, we get y equals plus or minus 1. Which one is it? The It's the minus one, cause we're in quadrant 3. Y is negative below the x-axis. So that's our thing, angle, we got -1, -3, square root of 10. We can quickly fill in the other ones. By using SOHCAHTOA. What is sine theta? -1 over root 10?
Yeah.
Without cleaning it up, that'll work. What about tangent theta? One-third. They're both negative, the negative cancel out. Secant theta is,
Negative square root.
yeah, just flip over cosine. And for cosecant, we flip over sine. And for cotangent, we flip over tangent. Alright, let's take a 10-minute break. Everybody stretch, use the bathroom, smoke them if you got them. I didn't record that bit, cause I don't wanna get back to her. Alright, so let's simplify each expression. I.e., write in as few terms as possible. Let's start with. Sine of 195, cosine of 195. Formula does this look like it might be a part of?
Cosine.
What are the formulas for the day?
Sine A plus B.
Yeah, well, sine of 2a.
Oh.
So sine of 2a
Oh, cause yeah, it's
was
same.
2 sine a cosine a. And if I call this a and a. We're missing a 2, right? To get it to match this formula, I'm missing a 2. So if I don't wanna change the value, but I wanna use that formula, I can multiply by 2. And then also multiply by 1/2. Does that logic make sense? If I want the 2, I can't just add 2, I can't just double it for no reason. If I'm gonna double it, I gotta take a half of it again. 1/2 times 2, this multiplies to 1. So I'm not changing the value. But then I can use this part to do the double angle formula. I can say 1/2 of sine of 2 times 195. Where the hell is 195 doubled? 390? I think it's 390.
It's 240.
Yeah, that's what I was thinking. I did 400 and subtracted 5 twice. So this ends up being 1/2 of sine of 390. Guess I should have degrees in there to make it clear these aren't radians. Does that get any cleaner? What angle is 390?
It's just 30 degrees.
It's just the same as 30 degrees. You can go to radians if you want, but we don't need that. What is sine of 30 degrees? 1/2. So this ends up being 1/2 times 1/2. And when you multiply fractions, you multiply tops separately from bottoms, we get 1 point. So that actually cleaned up into it's just a simple number.
So we could kind of disregard the revolution that we did with 360.
Yeah.
It's just-
Say 30 degrees.
We did, well, who's calling me 30 and how did you do it? Were you the one that said it? Go for it, Patrick.
I just subtracted 360 from 390, because the value over 360, you can just take
At
the.
the quarter mile or
They're called, it was actually called coterminal angles. Every multiple of 360 is the same.
okay.
So if we go around 360 and then go another 30 degrees. This is 360 plus another 30 gets us a total of 390. But this is the same spot as just doing it around 30 degrees from the start. Make sure everyone's on the same page. Okay. What about, this will be fun. 4 cosine. Let's say 4 cosine squared. Of 7x minus 2. I upped it. They had a little bit easier. But I said, fuck all that. Which formula has a cosine squared in it?
Sine of 2 theta.
Looks like 2.
Equals 2 cosine squared theta minus 1.
Minus sine squared.
That's, yeah, but we don't have a sine squared here, so I'm going with the one that doesn't have a sine squared. Are we close to that here?
Yeah, we have 4 cosine squared, but
We
they
could
would
say-
be 7x.
We can say theta equals 7x, that matches up. But we've got a 4 here and it's a 2 there. So what do I gotta do?
Divide by 2. Because it would give you 2 cosine squared.
What do you mean divide by 2?
Alright.
I could multiply this one by 2. Or I could factor out 2 out of this one. If I multiply this one by 2. I get 4 cosine squared theta minus 2. Right? The same thing goes on here, like I think you were going with divide out of 2.
Yeah.
But if you divide out of 2, we gotta do what we did up above here. Same idea. Either way, this ends up being 2 times cosine squared. 7x minus 1. So this is 2 times cosine. We're gonna say 2 times theta, and theta was 7x. So this will be 2 cosine of 14x. No, the cosine squared If we lose the square when we go down to the smaller version. Alright, so. Let's do that. And then I'm gonna dump a bunch of equations on you and say, these suck, I'm not gonna test you on this. But you need to see them and you'll end up doing stuff with them in the homework, I'm sure. But let's do one more, let's show you how to derive a multiple angle formula. Let's derive a formula. For cosine of 3x. Any ideas? What we learned this chapter, not just the double angles, but. Can I break 3x up into something I can use? X and 2x. Right? We can do that. So that was, looks like a plus b. So the a plus b one had. Cosine listed twice and they did minus sine listed twice. Right? And we'll plug in our a and our b, we've got an x and a 2x. X and a 2x. Now what? Let's say we want to aim for something in terms of cosine alone. So if I want that, I need to change the cosine 2x and the sine 2x, right? So the cosine 2x, we actually have one that goes directly to cosine alone, right? We could use 2 cosine squared x minus 1. And then I had minus sine x. And what was sine of 2x? What's its formula?
Two sine x, cosine x.
It is 2 sine x cosine x. So I'm gonna distribute that shit and see what we got. This looks like a 2 cosine cubed x now. Minus a cosine x. And this looks like minus 2 sine squared x cosine x. We're almost there. This is the only one we gotta deal with. Do we have a formula for sine squared x that just has cosine squared x or cosine x? One of the first ones you learned. So if I subtract cosine squared x from both sides. We're gonna plug that in there. So I've got two cosine cubed x minus cosine x. Notice I keep writing the other stuff down so I don't lose it. If you don't, you're gonna lose it and not have it in your answer. Guarantee it. Then I've got minus two. I'm gonna use a different color here to show what I'm substituting in. And then I had a sine x. So if I clean this all up. I've got -2 times sine x times 1. That's not a sine x, that's a cosine x. Look at me writing down the wrong shit. I was just supposed to bring that down right there. I've got -2 cosine x.
Can you explain how you got cosine x? I know you, don't you multiply the negative sine x times the cosine x?
Where are we at?
The right side,
Over here?
up there, how to get that cosine x?
It was up here.
You just brought it down, you didn't multiply.
I multiplied this multiplied that to get the sine squared.
You know,
Cosine was still there.
okay.
Yeah, it's still part of it. There's no way to combine it. So you combine what you can into exponents. And now I've got -2 times 1 times cosine x is -2 cosine x. That's doing that times that. And then I gotta also distribute it to the negative cosine squared x. I will have a minus is a plus, 2. And I'm gonna have a cosine cubed x there. I'm gonna do that part a little bit slower because I'm seeing some looks on faces that say you went too fucking fast. So this is what we're trying to do. I can multiply the -2 in first. And get -2 plus 2 cosine squared x. And then we're timesing that by cosine x. And now I'll distribute that one and to there and to there. So the first one gets me that, the -2 cosine x. And cosine x times +2 cosine squared x is 2 cosine cubed x. If we add all that shit together. Cosine 3x equals, I have a 2 cosine cubed and another 2 cosine cubed. I've got 4 cosine cubed x. And I've got -1 cosine x and -2 cosine x is -3 cosine x. Make sense? It's a lot of work, right? It's a lot of work. Every once in a while, it makes itself handy. Now we're gonna go over deriving a bunch of formula. I'm only gonna derive 2 formulas. And then do the one example with them and I'll write down the rest. You're not gonna like them. You're not gonna remember them. I don't remember. I really don't. I know how to get them. And that's why I'm gonna show you how to get them, because you're gonna be like, oh, fuck that, I ain't memorizing them, but if you remember how to get them. You can always get them if you don't have like, I don't know, the internet available at the time, and you really need it. So the next set is called the half angle formulas. Like cosine of 1/2 theta. Or cosine of theta over 2, which are the same thing. And I'm gonna show you how to get them. Cause you're gonna be like, nope, not memorizing these. Even Patrick. Even Patrick's gonna say no.
Yep.
I promise you, you're not gonna wanna memorize them. So to get one for cosine, I'm gonna start with cosine of 2 theta. I'm gonna use cosine of 2 eta. I'm gonna say cosine of 2a equals 2 cosine squared a minus 1. And solve for cosine a. A lot of these, if you just memorize a few formulas and do some algebra manipulation, you can get the rest. It's pretty neat. So if I wanted to do that, I could add 1 to both sides. And I would get cosine of 2a plus 1 equals 2 cosine squared a. And then I'm trying to get cosine a by itself, so the next thing to do would be divide by 2. And I'm actually gonna change the order of these, I'm gonna put 1 first, 1 plus cosine of 2a. Over 2 equals cosine squared a. And we will take the square root of both sides. And if I'm gonna write this one on the left, I'm gonna say cosine a equals, when you take the square root, you have a plus or minus. Okay. Now, to get the double angle formula,
What you do with the 2 at the top? Oh, you just divide it up.
just divide it.
Oh, okay.
All good so far? Now, I don't want a, I want like half of an angle, so I'm gonna say a equals 1/2 theta. What would 2a be if a is 1/2? Just be 1 theta, right? So I can say cosine of 1/2 theta equals plus or minus the square root of 1 plus cosine. We just said 2a is theta, 1 plus cosine theta over 2. Sine theta is done with the same cosine 2 theta. You just do the other formula with the 1 minus 2 sine squared. You will get, if you manipulate the sine one, or the. You get sine of 1/2 theta, it looks almost fucking identical. It's 1 minus cosine theta over 2. And to get to that one, you start with cosine of 2 theta equals 1 minus 2 sine squared. Tangent of 1/2 theta has a couple forms. The easiest one is just dividing these by each other. And you will get plus or minus the square root of 1 minus cosine theta over 1 plus cosine theta. Which is really sine of 1/2 theta over cosine 1/2 theta, just cleaned up. This has two other forms. It also equals sine of theta over 1 plus cosine theta without a square root. And it can also equal 1 minus cosine theta over sine theta. Like I said, you're not gonna remember these. To go from here to here. You multiply top and bottom by 1 plus cosine theta. On the inside of the radical. And you go to that one, you multiply by 1 minus cosine theta on top and bottom. And you do some formula cleanups. But those are the half angle formulas. This is why I'm not testing you out, they suck. But you should do the homework with them so that you have some experience using them. In case you do, I don't know, decide to start doing shit in with a job that actually needs you to do it, most of it's not really gonna do it, where you're gonna have to use this formula by hand. Those are collectively called the half angle formulas. Next ones, I'll show you how to derive. These are called the product to sum formulas. So let's say I want a formula for cosine A, cosine B. And I wanna write it where there is a sum in here, where they're not multiplied. Not multiplied. This is my goal. So this is how you go about doing it. You whip out the cosine of A plus B and the cosine of A minus B. Cosine of A plus B, oops, plus is on the inside. That was cosine A, cosine B. Minus sine A, sine B. And if I do cosine of A minus B. I have the same thing, but a different sign between them, right? If you haven't done any of the 7.3 homework, this is a bitch to remember how to do. Well, these are the things I want. I want that, that's what I'm aiming for. So what I'm gonna do is I'm gonna add. On the left side, I have cosine of A minus B plus cosine of A plus B. On the right side, I get 2 cosine of A, cosine of B. And the signs cancel out. Right? And signs cancel. I'm gonna write that so that you can see that it happens. If I have a positive 1 and a negative 1, I add them together, they go to 0. You're almost there. You just divide both sides by 2. So cosine of A cosine B. Oftentimes they write it with the 1/2 out front. And say cosine of A minus B plus cosine of A plus B. We have a product and now we have a sign. If you subtracted, you would have gotten the sign version.
Sine to sine B, right? Sine to sine B equal to,
Yeah,
okay,
with the minus here, this would be a minus,
yeah,
this would clear out and the minus is a plus. Now, if you want mixed terms where one's a sine and one's a cosine. We want like sine A cosine B. You do the same thing, but with the sine of A plus B and sine of A minus B. You manipulate those. If you manipulate those, you're gonna get 1/2 of sine of A plus B plus sine of A minus B. And this seems really weird, because they're just swapping the letters. But it changes the formula a little bit. We do cosine A, sine B. It's the same stuff, but you have a minus in between. This one is not helpful at all. The reason I say that is I could just use this one up here and say B is A and A is B. And switch the letters around, do a little like formula manipulation, and you can use the top one just by enabling them, labeling them differently. And you will still get the same thing. It doesn't look the same in the generic formula, but if you're actually working with like angles and shit, it does get the same thing. Those are the product of some formulas. Again, not testing on these, but you should do the work on them and have some experience with them. For the very, very rare events that they show up in later classes. And the only reason I'm not testing you on it is because I guarantee you, you are not gonna remember them the next time you need them outside this class. So there's no point in memorizing them now. You just need to have experience working with them.
Which ones are you testing?
The double angle formulas. Sine of two A, cosine of two A, and I'll probably throw in tangent of two A. And there's one more set. And I'm just gonna write down what they are. Cause the or the how to get them. You're not gonna wanna do, cause you're not gonna wanna remember. These are sum to product where we start off with like sine A plus sine B. And this kind of involves like you end up having like half angle formula shit going on here. This is 2 sine of A plus B over 2 cosine of A plus B over 2. I'm just writing them down so that you've seen them, I've taught them to you. And that way you'll know what to use when if they show up on the homework. When we get to the review day, when you guys are doing like the practice review, I will write a list of the formulas that are like the most important ones to memorize. Not just for the exam here, but for later classes. That cover the entire ones we've done so far. There's a couple more, if we wanted sine of A minus B. Sine of A minus sine B. That's a fucking, I did put the wrong side down there, that's a minus. You know, like I said, you ain't gonna remember this shit. I can't even fucking read my writing, it's that bad. This one has the minus now. And this one has the plus. And then we've got 2 for cosine. We've got cosine A plus cosine B. And this one results in both cosines. A plus B over 2 and cosine of A minus B over 2. And then cosine of A minus cosine of B is like the last one, but they're both sines. So like if I wanted to find sine of 22.5 degrees without a calculator. 22.5 is the same thing as 45 divided by 2. So I'm gonna use the half angle formula on 45 degrees. So sine of 22.5. It would have a plus or minus, and we're gonna cross out the wrong one in a second. You're doing 1 minus cosine of 45. And. Sine is positive in that quadrant, right? So our square root should be positive. We go with the positive one. I'm gonna break this up into two fractions for a second, 1/2 minus 1/2 cosine of 45. All I've done is split it up. And what value is cosine 45?
Square root 2/2.
Root 2/2. So this ends up being 1/2 minus root 2/4. Because 1/2 times root 2/2 gets us that. Which is ugly if you wanted a common denominator. You could multiply this by 2/2. This is why I'm not testing one, this is fucking lame. 2 minus the square root of 2/4. And that is the same thing as 1/2 the square root of 2 minus square root of 2. This would obviously look much better in the decimal form. But the decimal form is not gonna be exact. This is an exact answer, if you ever need the exact answer for something. That is sine of 22.5 degrees. Or sine of pi/8. Wake up, maker. Any questions? The last 20 minutes are they're fucking a lot of formulas and you're like, huh, and you're gonna, it's never goes away. Even when you have a fucking master's degree in this shit, you're like, huh? Like I can rederive them, but like still, huh? Why? Why fucking go? You don't ever really use them that much, but they're there in case you ever really do need them. That's why I'm not gonna test you on them, other teachers will test you on them. You pick the right teacher, I'm merciful in this subject.
So normally we have degrees that are like nice to round in, and then this one's at 22.5, so
Yeah.
that's the way to get that.
And I deliberately picked something that was at half of an angle you already knew the values for. So I started with sine of 45, I took half of it. We could get the 15-degree angles off of this, sine of 15 degrees. By using 30 degrees. Right? These ones are a must. I'm gonna test the shit out of you on them. And then they're gonna keep coming up, that's the problem. They just keep rearing their fucking ugly heads. So you're better off, there's only 5 equations there, and. Like this one, you can get the other two just by doing some algebra manipulation. As long as you remember cosine squared theta plus sine squared theta equals 1, you can manipulate this into this. Other than that, that's all I got for you, get the fuck out, have a good day. I don't know.